So, welcome to my dear students and learners. So, today this is also one requested video. So, today we will discuss about the gamma. Uh, I mean, Today we will discuss about the gamma uh, spectroscopy and radioisotope detection. So, it is. I am giving you a very concept means very basic idea how this what is this gamma spectroscopy and how it is this signature of a particular isotope or a mixture of some radioactive material, how it is generating the specific histogram. So that I will discuss today. So basically we know all what is radioactivity. This is nothing but the excess energy is emitted from a nucleus of an unstable or the radioactive material. But can we use that particular radiation to identify the radioactive materials? Yes. With this, basically, like our say our hand geometry or our thumb impression, like this was a this these are the like your hand geometry, thumb impression. Those are unique identification for a human beings that will not match with any other people. Okay, so like that, the the energy which is getting emitted from the unstable or the excited or the radioactive nucleus, that is, and its intensity, it is very unique in nature. Okay, the energy level and its intensity, that means the pulses, means the whatever the pulse, I will come later, whatever the uh, energy it is getting radiated from the nucleus, that amount of energy, naturally it will be in a kilo electron volt or mega electron volt. So that energy and its intensity, means the number of such radiations, are very unique. So if you able to capture it and properly reprocess it, and if that things is compared with some known already available signature, then you can uh, predict uh, that what kind of particular isotopes are available inside the mixture of the uh, radioactive material. Okay, so normally we know that there is alpha, beta and gamma. So now we will be, for this, as the name suggests, for this we will focus on gamma radiation. Okay, basically you know what is called the isotope. It is in same atomic number but different mass number. Their chemical behaviors are same, but that their uh, atomic level structure and its behavior is quite different. Okay, so the gamma radiation occurs when an unstable nucleus release energy as photon. Okay, this photon energy depend on the particular isotope, as I told, from which isotope it is getting uh, released. It is depend on that only. Hmm. And likewise, when some radioactive isotope decay, it decays, so it produce the photon with particular energy and number of such uh, mm, energy, number of such energy will be releases. Okay, so now if you are able to capture it, this energy, then with this we can understand the composition or the particular isotope. Okay. So by studying this amount of energy of the photon and its intensity, okay, we can identify which isotopes are present in a particular fuel composition. So basically this technique is called gamma spectroscopy. Hmm. So how it works? So particular one sample, when it is placed in front of a nuclear detector, so this sample will release photon, and it will uh, travel inside the uh, detector crystal, and after going there, that energy will released in that detector crystal. Okay. So I will share one link in the video description, where the basic nuclear detector how works and what are the types, then you can see it, you will understand. If you want to know in details, then you can follow that particular link. So now say this is the gamma detector, and this is the crystal, and this energy, these are the energy getting released from that particular sample, unknown sample, whose composition uh, you want to measure. So now once the energy is released, deposited here, okay, this energy will cause some charge unbalance in the nucleus, and this will cause some electron flow through the external circuit connected with it, even though it's very low amplitude and all. Then you will get an electrical pulse. Okay. So this, the height of the pulse, the height of the pulse, basically it will indicate the extent of energy, the extent of energy from where this energy is coming. This is coming from the radiated energy, which is coming from that particular sample, that is going, that is traveling inside the nucleus of the detector crystal, and that excitation will cause the electron flow, and that electron flow basically it will generate the electrical pulse in an external circuit. So basically the height of the pulse, it will indicate the energy level of the incident photon. Okay. So once this kind of there are lots of radiation, means that photon is getting captured or in the detector, so number of pulse it will be generating with different height, because that energy level will be uh, one photon having different kind of energy, and it is coming randomly. Now with that you cannot do anything, you have to do some post process. So for that you need one particular equipments or instrument which is called multi-channel analyzers. Now you are very familiar, people who are dealing with the fuel uh, particular enrichment checking, they are much familiar with this one. So here you see you will get some peak, this is one peak, this is one peak. Seeing this peak, okay, the intensity. So this is basically a typical form of a, this is a typical signature or the typical presentation of a gamma spectrum. Okay. So how to understand? Let us, how it is this kind of shape is coming. Basically, the incident photon radiated incident radiation from the radioactive material, it will cause a pulse. But how you will get like this? What is the inference? Let us understand. This I have taken one random example. So these are the uh, schematics schematics of the electronics. It's a very, because this electrical pulse which is getting, it's not so simple, even though the concept is very simple, but the post processing, because those are, you can understand, one electron, few electrons, that will cause the current flow of in micro ampere range. So very small amplitude, the magnitude will be very small, that is to be amplified. Hmm. And low amplitude uh, signal, the sensor signal, if you want to amplify the signal to noise ratio, it will drastically, it will come down. Hmm. So those are so many factors are there, it's not so easy to understand. Let us take this example, that from, say, this is one sample kept here, so this is to be identified. Okay, so from there, this lot of photon, it is getting incidented in the crystal randomly, uh, and for a particular time frame, say, for, I taken the sample up to this time period, up to, say, that is 5 minutes, for example. So till 5 minutes I am getting this, say this height is 200 kilo electron volt, and say this is 300 kilo electron volt, and say this is 100 kilo keV. So in the detector, once the sample you kept and you wait for 5 minutes, so first you are getting 4 200 keV pulse, then one 300 keV pulse, then again one 200 keV pulse, then again one 300 keV pulse, then again one 200 keV, then again one 300 keV, then 100 keV, then again 200 keV, then 200 keV, then again 200 keV, and then one 300 keV. This kind of pulse you are getting randomly. You are getting, okay. Okay. Now this multi-channel analyzer, what we will do now, if we from this random pulse, if now I post process in a very specific fashion, okay, then what it will come. So you see, basically during that particular period, 5 minutes, we are getting 300 kilo electron volt keV pulse, 8 200 keV pulse, and 5 300 keV pulse. So this is the tabulated form. Now if I plot x-axis, if I plot x-axis, energy in x-axis, energy level is in x-axis, and number of that particular pulses in the y-axis, then what kind of graph we will get? This one. So this your x-axis is kilo electron volt or the energy level, and the y-axis is number of pulses, and this peak, it is unique for a particular isotope. Okay, so say this isotope is, say this curve is applicable for NXM. Sorry, yeah, whatever maybe. So this is that is the particular peak, and if it is matches, then you can tell that isotope is the isotope X. So basically, this is done in multi-channel analyzer. You know very well. So what basically in that x-axis is the channel number. X-axis is the channel, and y-axis is the count. Hmm. So now say that is that particular mm, uh, multi-channel analyzer. Say it is a 10 bit. For example, it's a 10 bit. That multi-channel analyzer is 10 bit. MCA is 10 bit. So 10 bit means how many channels? 1024 channels, around 1000 channels. And say you want to measure up to say the a particular composition, hmm, having the maximum energy of say 3000 keV. 3000 keV. These are the just typical example. So per channel how much? Around 3 keV. Around 3 keV. Now what you will do? What you have to do? You have to take the you have to place the gamma detector near to the very near to the sample which is to be identified. Then you switch on the gamma detector, and in the display you can see the pulse it will be first set of pulse it will be like this. That means what I mean to say, when time is getting elapsed, the curve shape, you see this all the curve, this all here say there are 5 curves are there, the shape is same, only it is getting uplifted. That means you once you are taking sample, then you are getting particular energy level, say for this peak. So your x-axis is channel or the energy. So say at time is equal to t1, you are getting say 10 such pulses. Up at t is equal to t2, you are getting 20 pulse. That's why it is going up. And after a certain time, you need not to go for so that is depend on the how much time you have to collect the capture the pulses. That is depend on the decay characteristics of that particular these things. Okay, normally some people will follow 1 hour, somebody 45 minutes. With that you can this the peaks will be formed. Okay, and with that you can understand, say here how many peaks are there. So this is one peak, this is one peak, this is another peak, and this is another peak. So basically inside the sample, from where you will get such kind of peaks. So you can, so seeing this you can understand this is one isotope, this is one isotope, this one isotope, this is one isotope, or maybe some two peaks will be coming from particular isotope and another two is coming. So this by uh, comparing this particular graph, particular picture with some already known histogram of this gamma histogram or the gamma spectroscopy of a known isotope, you can very easily predict that what kind of composition of that particular fuel is. Now counts, if you want to find out the counts, then basically what you have to do, say this isotope is say this isotope is x, this peak this peak, particular peak, it is indicating a isotope x. So to find out the number of counts, you have to integrate from this to this. Then so many things are there, so that will be give you the total count. Okay, then you have to with from the total count, you have to minus the background count, then it will come net count. And the nature of the material, or the particular mm, uh, that particular this one, it will be decided by seeing the net count normally. So gamma spectroscopy is extensively used to identify a particular radioactive material or a composition of a blend or a mix of 2 3 radioactive material. So how it is done? Basically, it is a gamma detector. The working principle is very simple, as a nuclear detector, as good as a nuclear detector. So inside there will be a, sometime there will be a crystal or another fission chamber will be there, where the inner lining will be coated with slightly enriched fissile material. So once this gamma or the photon is getting incident on the nuclear detector, so the sensing element or the fission chamber or the crystal, whatever may be, is in the detector, that nucleus is getting excited, and there is a transaction, or there is a orbital change, means the new electron will try to jump from uh, one orbit to another, and which will cause some electron flow through the external circuit if a potential difference is created. Okay, so this basically it will this will cause a current flow through a external circuit that is detected as pulse. So the height of the pulse basically is the, it will show the energy level or the energy of that particular, more energy, more excitation. More excitation means more electron through the external circuit. So this will, pulse height is basically representing the um, uh, incident photon energy which is coming from a particular radioactive nuclei. Then in a multi-channel analyzer, how many, what kind of energy, what kind of means how many types of pulses are coming with different energy, and how many numbers, which is called intensity, that is segregated and finally is plotted as this. So this is called your gamma spectroscopy, and from there you can able to identify the, as these peaks are unique for each and every radioactive nuclei. So by comparing this obtained spectroscopy with the known peaks, with the known peaks of a spectroscopy, you can understand what kind of material it is. And by um, by by calculating the total number of counts or the net counts, you can uh, get the enrichment level of the particular fuel. Okay, hope it is late night, it is 1 o'clock, it's my time to sleep. Hope something you understood. Any other slides are there? Where I ended? Okay, that's all. So thank you so much. Thanks for your patience.